On to part 3 of our assessment, we have growth and decay. So for our growth word problem, we have the population of Grapefruitopia was 23,500 in the 2000 census, t equals 0. Based on the data from the U.S. Census Bureau, it has shown a 2.3% growth rate. So A wants us to find the population of Grapefruitopia in the year 1990. So we have our growth slash decay formula of which is A of t is equal to a sub 0 e to the k times t. Plugging in our values for A using our formula, we'll do A of t is equal to 23,500 because that is the t equals 0, so that's how much there was when t is equal to 0 to the e, or times e, and e is going to be to the 0.023 because that's our growth rate, and then times negative 10 because it's going backwards to 1990. And then plug this into decimals and we'll get A of t is equal to 18,672. So there was 18,672 people in Grapefruitopia in the year 1990. Looking at B, we want to find what the population will be in 2070. So this we're going to do the same thing as we did in the first problem, but instead of negative 10 times our growth rate, we're going to have times 70. Because now it's 70 years past the t equals 0, which is 23,500 people. And solving this using decimals, or just plugging in the right side of our equation in, we get A of t is equal to 117,567. And looking at C, we want to know when the mayor should build the statue for the population reaching 50,000. And we don't want to know how many years, we want to know the exact year that this will happen. So instead of changing our t value, the t is what we want to actually find. So using the 50,000 population that we were given, we can just plug that in as our A of t. And then to solve, we divide by 23,500 and take the natural log of both sides, getting rid of the e. And then we'll divide by 0.023 because that's what's going to be left after the e is gone. And we'll be left with t is equal to natural log of 50,000 divided by 23,500, and all of that divided by 0.023. When plugging that into decimals, we'll get t is equal to 33, which means the year will be 2033 when the mayor can make the statue. And for a decay problem, we have the half-life of some radioactive substance is about 170 years. NASA recently discovered a sample of 9 grams located in OK, Oklahoma. Looking at A, the question that we want to find the answer to is what is the decay rate for silicon-32? And we have a hint that the rate itself is always positive. So we write down our growth problem, or not growth problem, our growth formula again. And then what we want to do is, since we know the half-life, we know that our A of t is going to be half of A sub 0. So we do 1/2 A sub 0 is equal to A sub 0 times E, and E is to the 170k. So first we can get rid of A sub 0 on both sides by dividing by A sub 0, which eliminates that. And then taking the natural log of both sides, we can get rid of E. And then we divide by 170 to get k by itself. We'll have the natural log of 1/2 divided by 170. And then plugging that into the calculator, we'll get negative 0.004077, because we want to make sure we still have enough value to make our percentage more correct. And turning that into percentage, because we don't want the growth decimal, we don't want our rate in a decimal, we want our rate always in a percent. We'll make it positive, and it will be 0.4077%. And that is it for the growth and decay.